In this video, I will demonstrate how to place a sediment basin using a civil cell. We will create a new file and bring in the required references. We will reference in our terrain, our corridor, and our alignment. We want to view the contours of our existing terrain. So while it's referenced, we'll select it and go to Properties. Override Symbology, we'll go Yes. For the override template, we'll use Contours. We will use our contours to aid us in giving us the best fit for our sediment basin. In order to get a closed shape for this civil cell, we'll navigate to our Site tab. We want to draw a basic polygon. We'll use Template DNC. We'll do a null feature definition. We can smooth out these vertexes using different radius values, or we can add or also delete our vertexes to change the shape as desired. Once we've settled on a desired shape, now we'll profile the feature definition. We want our pond to be flat, so in order to do this, we'll navigate to our geometry, element profiles. We'll use profile by constant elevation. Select our shape. We use an elevation of we'll start out 410 and select the feature definition. Next, we'll view our element in 3D. Before we drop our civil cell, let's don't forget to set our terrain active. So navigate to Model Detailing, Place Civil Cell. Go to Erosion Sediment Control and select Sediment Basin. Select OK. Now just follow the prompts. Right click, reset to skip. Left click, accept civil cell placement. We can go through some of these areas and apply larger radiuses. And we can also adjust our profile grade. Once we have the desired shape and a good profile grade elevation, we want to make sure that we have enough storage volume in our pond. To get this volume, we'll go to Home, Civil Analysis, Analyze Pond. We have a prompt that says Locate a Terrain Model. If you go to the 3D view, you'll notice an element that has a terrain model called Max Water Level. This is already placed in the civil cell, and it accounts for 1 foot of freeboard. We can go ahead and select this element. And this dialog window will come up. So we'll look at our volume, and is given in cubic feet. In order to save this, I usually just take a screenshot and just save it in my project folder. But if you need extra volume, you can add vertexes to your polygon, or you can adjust your profile grade. Next, we would like our entire basin to be a terrain so we can analyze the cut and fill that it will take to build the pond. So to do this, we'll navigate to Terrain, create Additional Methods, create Corridor Alternate Surfaces. So we'll select our corridor handles. Next, we want to change our terrain properties. So we'll select their boundary. Edge method, we can go max edge method. We use like 20. This will help tighten up the triangles. We want to go ahead and apply a surface template. So go to Model Detailing, Surface Template, Apply Surface Template. Locate a terrain model. No clipping boundary. We have to choose Alt down to select the appropriate surface template. Erosion control product. Select OK. Left click to accept. Now we have a surface template applied to our sediment basin. Lastly, we want to look at the cut and fill volumes that it will take to create the pond. First thing I want to do is go to Place Text. Now I just want to come in here and simply select a text style and just close the window. For the analysis, I want to go to Home, Civil Analysis, Analyze Volume. We want to use this option, Terrain Model to Terrain Model Volume. From Terrain Model, Sediment Basin Terrain to our existing terrain. We just left click through the prompts. Right click, reset for none. Say volume yes. We can use these cut and fill volumes in our calculations for our basin. At this point, as long as it's still a civil cell, we can adjust the polygon shape, and we can also adjust the profile grade. We can also adjust the radiuses if we need to. In doing that, we will need to reanalyze the pond volume and also reanalyze the cut and fill as well. And this concludes our video.